Assalamu alaikum students, how are you? Today our topic is refraction of light. We know that light travels with a very high speed, that is 300,000 km per second in air. Light travels fastest in the vacuum. Light does not need a material medium to travel, but light travels with different speeds in different materials. Light slows down when it enters a different materials such as glass or water. When light passes from one transparent medium to another transparent medium, its direction and speed both changes. That is, it bends. If a ray of light meets the new material at an angle, it bends. This bending of light is known as refraction of light. The ray of light that falls on the surface of the new material is known as incident ray, and the bent ray of light is called refracted ray. We can see that this is a glass slab, and this is the incident ray of light that enters this glass slab from air. As soon as it touches its surface at this point, this is known as point of incidence, it changes its direction. You can see that it has bent, and this is the refracted ray. Again, when it travels from glass to air, it speeds up. As we know that the speed of light is greater in the glass greater in the air as compared to glass, and when it's come out of the glass, it again speeds up and it bends away from the normal. Normal is an imaginary line that is drawn at a point of incidence. It is drawn perpendicular at the point of incidence. The ray, emerging ray, this is the emerging ray, and this is the incident ray. You can see that both these rays are parallel to each other. We can see the phenomena of refraction of light by putting a pencil in a glass of water. You can see that this is the water line, and it appears as pencil has been broken at the water line. This is the very clear phenomena of refraction of light. You can also perform it at home. Now we are going to perform an activity to prove the refraction of light. For this we require drawing board, white sheet of paper, glass slab, common pins. Students, I have fixed the white sheet of paper on the drawing board. Next, I have put the glass slab in the center of the paper. Next, I have to mark the boundary of the glass slab like this as A, B, C, D. Now, I have to put two pins, common pins, in such a way that they make an angle with the surface A and B. Now I am going to put these pins. I have fixed these two pins P and Q. This is pin P and this is Q, in such a way that they make an angle with the glass slab. Now I am looking on the other side of the glass slab for the images of the pin PQ, and I have to fix two pins QR in such a way that they come in a line with the image of the pins PQ, and I can see that this pin will come in a line with the image that I am seeing from this face of the glass slab, and this is in line with this image of the PQ. Like this, these two pins are in a line with the image of these two pins PQ. Okay. Now I have removed the glass slab and marked the position of the pins. I am going to join PQ as the incident ray, and it touches the face AB at point O. This point O is the point of incidence. Again I joined the RS as the refracted ray to CD, and it touches the line CD at point L. Next I joined the O and L. Then I have drawn up normal. Normal is an imaginary line that is drawn perpendicular at the point of incidence. And the angle between the normal and the incident ray is known as angle of incidence. And the angle between the refracted ray and the normal is known as angle of refraction. Now we can see that as the light enters from one transparent medium to another transparent medium, it changes its path, it bends. This bending is known as refraction of light. Now we are going to explain refraction in different mediums. Some mediums are rare, some are denser, means they have greater density. Water and glass are denser than air. So as soon as the light enters the glass or water from air, it slows down, its speed changes, and that's why its direction also changes. We can see that in this diagram, the light is entering from air. Air is a rare medium into a glass, that is a denser medium, and as soon as it enters the water, it changes its path. This is the actual path of the ray of light, but when it enters water, this path changes, it bends, and it bends towards the normal. We know that normal is an imaginary line that is drawn perpendicular at the point of incidence. This is the point of incidence. So this is the angle of incidence, this is the angle of refraction, and we can see that in this case the angle of incidence is greater than angle of refraction. We can say that when light passes from a rare medium to a denser medium, it bends towards the normal. Clear? And the case is opposite when light travels from a denser medium to rare medium. Here there is a ray of light that is emerging from the water in the air. As soon as the light passes from water to air, it reflected away from the normal. Because its speeds again become greater than water, now the angle of incidence will be less as compared to the angle of refraction, because the ray has bent away from the normal. This is the normal, and this is the actual path of the ray of light. This is the refracted ray that has been bent from the normal. If a material is very dense, the light slows down more, and so more refraction occurs. We can compare this with in this diagram. This is the ray of light that is entering from air to glass. Its bending is less because glass is less dense as compared to diamond, and we can see that in diamond, when this ray of light enters from air to diamond, it has been refracted more because diamond is more dense as compared to glass. Our next topic is apparent depth. One of the effects of refraction is that brain can be triggered into thinking that things are in different place from where they really are. Sometimes refraction of light gives us a false impression of the depth and position of the object in glass or water. We have noticed that clear swimming pool looks shallower than the actual depth. It is because of refraction of light. Light travels faster in air than in water, and when light passes from denser medium to a rare medium, it bends away from the normal. When this refracted ray enters into our eyes, the bottom of the pool and the stone lying at the bottom of the pool appear close to us than they really are. Fish can compensate for the refraction between air and water. This is how they can catch insects at the surface and avoid predators such as herons. 1. What is refraction? The answer will start from this line up to this line, including this diagram. Question number 1, part B. Describe how a ray of light is refracted when it passes through a glass block. The answer will start from this line up to this line and then again from this line up to this line, including this diagram. Question number 2. Explain why light bends more when it passes through the diamond than it does through the glass. The answer will start from this line up to this line, including these two diagrams. Question number 3. Explain why things look as if they are in a different position when seen through water. Answer is, since a refracted ray is parallel to a ray of light entering the water, the object appears to be in a different position. Thank you.